everyone. I am Somayeh Kalhor and I will present an article entitled Experimental Evaluation and Comparison of Anti-Pattern Detection Tools by the Gold Standard in this conference. We first know what is a software anti-pattern. Every violation of object-oriented principles such as maintainability, reusability, and integrity can lead to software anti-patterns. Poor programming or poor design in the software development process can lead to software anti-pattern. They should be refactored. The refactoring is a sufficient operator to eliminate every software anti-pattern. Most critical step is anti-pattern detection. Other terms that used in studies for anti-patterns are bad smell, code smell, and defect. They different with fault and error. We classified anti-pattern detection approach in three categories. In initial study, informal definition of anti-patterns presented and they manually detect. In further study in this field, formal anti-pattern detection rules created. With this rule, we can manual analyze the source code. A rule is combination of quality metric and data ratio. Logical operators are used to combine this metric. Different rules in different study have been proposed, and some survey articles compare them with each other. Final approach for detection is use of tools. We consider 4 anti-pattern detection tools in our study: iPlasma, CheckStyle, PMD, and JSPrint. The website addresses that you can download these tools is available here. We have chosen these anti-pattern detection tools for 4 reasons. They frequently used in previous study. They are available for download and they can create a list of entities that suffer from anti-pattern. Some tools such as Stench Bluesome for anti-pattern detection mark lines of source code, and we must search all lines to find anti-pattern. Tided black box only create a number of entities that suffer from each anti-pattern. And final reason is that we can compare result of these tools with gold standard. We have selected in our study 3 open source programs to compare detection tools: JHotDraw, JRefactory, JUnit. They are available in these addresses. They are chosen because they are frequently used in previous study. They have different sizes from small to large, and to better understand the tool's power, we must run them in various software sizes. They presented as gold standard by SQL Lab. SQL Lab is a team of PhD and master's degree students in software engineering. They manually detected the smelly entities and made a list of method and class name and their addresses in source code that suffer from bad smells. Their result is available in PDF file. We use 3 anti-patterns in our study. One of them is large classes, a class that alone does much work on the software system. Other classes do only detailed services. This class violates the single responsibility principle. This is similar to brain class. Long method is other anti-pattern and is similar to large class, but in minor subsystem. In this anti-pattern, many class functionality have been done by a method, and other class methods only do detailed works. Other considered anti-pattern in our study is feature envy. A method is more interested in doing the process of other classes than its own class. You can see in this figure method A1 access to feature B1 and feature B3 in class B, and also call method C1 in class C. In the other hand, method C1 access feature B1 and feature B2. As a result, the method A1 has access to the features and methods of other classes 3 times directly and 2 times indirectly, but only 1 time access to its own features. We have chosen these 3 anti-patterns because they are among the most common anti-patterns in previous study. They manually analyzed by SQL lab. They can be detected at least by 2 tools considered in our study. This chart shows the comparison of detection tools to detect large class. This has 4 sections. In section 1, PMD large classes are shown. In section 2, JSPRIT large classes are shown. And in other sections, respectively, iPlasma and CheckStyle are shown. You can compare this section with each other. To compare anti-pattern detection tools, we run them on each of target open source software to detect large classes. Then the average number of results generated by each tool on 3 open source software is calculated. In this chart, for example, PMD and JSPRIT large classes show the number of shared large classes in result of these tools. In this chart, you can see the comparison of detection tools to detect long method. This is similar to comparison tools for large class. Every tool run on each of target open source software system to detect smelly entities. Then the average number of results generated by each tool on 3 open source is calculated. In this chart, you can see 4 sections similar to large class chart, and also you can compare this section with each other. For example, you can understand JSPRIT long method methods are more than other tools. In this chart, you can see the comparison of detection tool to detect feature MV. This chart has two sections because check style and PMD tools can't detect this anti-pattern. Therefore, comparison are done in iPlasma and JSPRE tools. You can see JSPRE can detect more anti-patterns than iPlasma. To compare considered anti-pattern detection tools in our study, we have used precision and recall criteria. Precision is the ratio of number of anti-pattern detected in software correctly over the total number of detected anti-patterns by tools, and recall is the ratio of number of anti-pattern detected in software correctly over the total number of detected anti-pattern by gold standard. These concepts are shown with these presented formulas. TP, true positive, is number of software entities detected in both gold standard and tool as anti-patterns. FP, false positive, is number of program entities that aren't at the gold standard as anti-pattern but are incorrectly detected as anti-patterns by the tool. FN, false negative, is number of program entities that are at the gold standard as anti-patterns but aren't incorrectly identified by tool. This chart shows the precision and recall values in various tools, and you can compare them with each other. It shows in all considered tools precision and recall values to detect large classes and long methods are high because detection rules to detect these anti-patterns in various tools and gold standard are similar. But to detect feature NB, there are different rules. Therefore, the precision and recall values are low. Recall value in detecting two large class and long method anti-pattern is high, but precision value in long method detection is lower than large class detection. Any of tools in feature NV detection don't work well because the detection rules are different. This study provides a comprehensive view to software developers by comparing different anti-pattern detection tools and help them to choose the right tool to detect anti-pattern in their software. Finally, thanks for your attention. Goodbye.